Well, hello there. Thanks for stopping by. We're going to check out how to find the surface area and the volume of a cone. And I guess a cone is pretty self-explanatory. It kind of looks like an ice cream cone upside down. Too bad the ice cream isn't here, but the cone itself is what we're going to be talking about today. And from this picture here, you can see some words that we need to know with regards to cones, okay? This is a three-dimensional shape here. From the top to the bottom, kind of like a tent, we would call that the height. The radius, just like a circle, is the distance from this spot right here to the outside of the circular part, okay? The slant height is the side, it's like the part you would slide down if you were sliding down this. And the vertex is just the pointy part at the top. And if you've watched the videos that I have on cylinders and also watched the video that I have on pyramids, what you'll know is that if you were to draw this inside wow, that's a terrible drawing. If we were to draw this inside a cylinder, it would just fit exactly inside this cylinder. We could find the volume of this cylinder, and if you divide the volume by 3, you will have the volume of a cone. And remember, the volume of a cylinder is just pi r squared, so the area of the base, and you times it by this height right here, or this height as this dotted line shows, times the height. But when you have a pointy shape that would hurt to sit down on, like a pyramid or in this case a cone, you take that formula for the shape that would not hurt to sit on, in this case the cylinder, and you divide by 3. So in other words, 3 of these cones, 3 of those volumes could fit inside this cylinder. If we were to draw a cylinder around this, you could fit 3 of these cones. That's quite amazing. Anyway, I know you're highly amazed. Let's actually do some questions now that have to do with the surface area and the volume of a cone. Now, first of all, there are 2 formulas that you'll need to get familiar with. The first being the surface area right here, pi times r times s. Remember, s is the slant height right here, this slant height, okay? Plus pi r squared, and that's r being the radius, the distance from the middle to the outside, which would be not 8, because that is the diameter of the circular part. It would be 4. Okay, so 4 would be the radius, 8 is the diameter. Okay, so let's get started. Let's actually do the surface area right now. So the surface area, I'm going to use the formula over here. We're going to take pi, which is 3.14, just like all the other videos I've made have mentioned. And you're welcome to also learn about pi if you watch a video I have called Why is Pi 3.14? It's kind of interesting. Anyway, multiply pi by r, which we said over there is 4, times the slant height, which is 16. Okay? Plus pi r squared. So pi times, I don't really need brackets around the pi, times 4 squared. Okay? Forgive the messy writing. I'm going to use a calculator. I'm going to pull it up here, the good old Windows calculator. And I'm going to go 3.14 times 4 times 16. And that gives us 200.96. All right. And now let's go pi times 4 squared, which is pi times 4 times 4. So 3.14 times 4. I'm just going to push the squared button. And the answer is 50.24. Okay? And if I were to add these both together, 200.96 plus 50.24, I would get 251.2. Now we should use the units, so it's centimeters. And because we're talking about surface area being the outside area or the material needed to make a cone, okay, the material needed, we would put a squared here. So whenever we're talking about area or surface area, we always put a 2 right here. This is just a symbol, okay, for area. So 251.2 centimeters squared, or 251.2 square centimeters. It depends how you prefer to say it. Okay, so that is surface area and how to use the surface area formula. Let's move on to volume now. If we were finding volume, we would use this other formula here, and it would be pi times the radius again, which we know is 4 squared, times h. Now we have to be really careful here. H is the distance from this circular part, I'm going to draw a dotted line, all the way to the tip or the vertex of this cone. So we have a triangle here. It's a 90-degree triangle. We have 4 right here. We know that's 4. We know the hypotenuse of this triangle is 16, but we don't know this height, and we have to quickly find it. And the way to do that very quickly is to use the Pythagorean theorem. So and we know the hypotenuse, so please watch a video on the quick method for using the Pythagorean theorem. I have a video on that. But for now, I'm just going to quickly solve that. So we're going to go 16, the hypotenuse squared, minus 4 squared. And let's use our calculator. So 16 squared minus 4 squared is 240. And then the final answer of that would be if we found the square root of 240. Okay, so we'll take the square root of 240 and we get 15 point, we're going to round it off, 15.5. That means this height is 15.5 centimeters. And it's a good thing it's less than 16, or else I know something would have gone wrong, because 16 is definitely our hypotenuse. It's our longest side. So 15.5 is slightly shorter. Must be a very skinny cone though. Anyway, we know this is 15.5 now. 15.5. That is the height that we were looking for. And then we take all of that, just like I was talking about earlier, and divide by 3. Whenever you have a pointy object that's three-dimensional, you're going to have to divide by 3 when you're trying to find the volume. Okay? For pyramids, etc. Okay, let's multiply this all out now using our trusty calculator. So we have 3.14 times 4 squared, which is 16, times 15.5. And we're going to take that answer and divide by 3, and we get 259.6. I'm just going to round it off. 259 point, wow. I did say 259, didn't I? 259.6 centimeters. And then once again, we have to think about the symbol that would go right here, a symbol. If we put a 2 here, we're talking about area. So we want to put a 3 there, or cubed, because it symbolizes three-dimensional or 3D objects. Okay, it's the volume. It's the volume. Okay, so 259.6 centimeters cubed, or you could say 259.6 cubic centimeters. Okay, let's do another question. Here we have a situation where we have a cone. We know the height is 35. We know that the diameter is 20. So let's write in some things that we know. We know this radius, because we're going to need the radius, is 10. We know this height right here is 35. We do not know this hypotenuse here, so chances are we're going to need to find that. I'll put the little 90-degree angle symbol right here. We will have to use Pythagorean theorem to find this when we're looking for surface area, because surface area needs the slant height. Okay? So, in fact, let's do that right now. Let's find the surface area of this cone. So, start by writing down pi times the radius, which we see is 10, times the slant height. Okay, let's do it in blue. Let's figure out the slant height right now. It's the Pythagorean theorem. And because we don't know the hypotenuse, we're going to take 35 squared plus 10 squared. Okay, and get out your trusty calculator. 35 squared plus 10 squared is 1325. We know this is not really 1325, so we have to do one more step. Hopefully you remember it as well. On the Pythagorean theorem, to get the final answer, we need the square root of the answer you get. So the square root of 1325, which is 36.4. So 36.4, I can write that right here if we want, 36.4 centimeters. And that makes sense because it should be longer than our height right here. And it is. So let's get our green pen and keep going. We need to go in brackets 36.4 right there plus pi times the radius again squared. And let's start figuring this all out. Get our trusty calculator. And let's multiply this. 3.14 times 10, which is 31.4. And then let's multiply that by 36.4. And you get 1,142.96. Plus 3.14 times 10 squared, which is 100. And you get 314. We could have done that without a calculator. No worries. Okay, let's take 314 and add on what we had, the 1142.96. And here is our surface area. 1,456.96. We could round it off to whatever we like. If we were rounding off to one decimal, this would actually end up being 1,457.0. But I'm just going to leave it like this for now. Centimeters, and we know we have to put a 2 here, which means we're talking about area. There's the surface area. Okay, let's find the volume now. And the volume, I'm going to delete the ink. The volume can be found. This is going to be quick. We're just going to go pi times the radius, which we know is 10, times, well, squared, times the height, which is 35, and divide that all by 3. So let's just do this really quickly. We can do it all in one step with our calculator. Here we go. 3.14 times 10 squared, which is 100. So we really have 314 times 35 divided by 3. And our final answer is 3663.3. I'll just round it off to one decimal, and that is centimeters cubed. There is our volume. See how this isn't so bad? As long as you can remember the Pythagorean theorem for certain parts, you're fine. We have just one last question here, and it says a cone just fits inside a cylinder with a diameter of 8 meters. So I'm going to draw this right now. Here's our cylinder. It's a little bit better than the first one I drew. Now we have a cone inside here, so I'll make it upside down cone. It doesn't really matter as long as... So there's our cone that just fits inside this cylinder. The diameter is 8, so all the way across from here to here is 8 meters. And the height of it, the height of this thing is 11 meters. Okay? What is the volume of the cone? Okay, so the volume formula, remember, is pi r squared h, because that's the volume of a cylinder, which I recommend watching if you have a chance to watch that video, and then divide by 3 because we're talking about this cone. This isn't such a tough question after all. So pi times, what's the radius? It is not 8. Be careful, the radius from here to here is only 4. It's half the distance. Okay, we have to square that, multiply it by itself. The height is 11. Thank goodness they gave that to us. And we can take out our trusty calculator. 3.14 times 4 squared, which I know is 4 times 4, which is 16, multiplied by 11, divided by 3, and we are left with 184.2. 184.2. Don't forget units, meters, and we're talking about volume, so include that 3. And that is our volume of this situation. I hope that helps. I hope you have figured out and realized that this isn't so difficult. It sure helps to have a calculator, and it sure helps to have watched in the past the video on the Pythagorean theorem. The quick method is definitely my recommendation to you if you haven't already. Okay, take care everyone. Good luck, and I will include some links to other videos across the top in case you want some other surface area and volume type style videos. Good luck in your own math world. Take care.